All right, fresh back from spring break. 5, 4, 3. And we're back for section 12-1, which is, by the way, live studio audience, this is the last chapter of the year. Then after that, we take 64 kids and shove them in the brackets. Place them in the brackets. Okay, place them in the brackets. Then we have May Madness coming up very soon. That's a good thing. It's everybody's favorite part of you guys. Okay. All right. So, kids, let's begin the last section of the year, right here, the last chapter of the year, right here. Okay? And let's start out by seeing if anybody knows how to do today's buzzword. Right? This is a triangle.
I would like to learn how.
Okay, well, hopefully you remember, but if you don't. Under the category of this rate, you haven't taught this to us in the last 24 hours, so there it goes. Okay. Now,
Pretty much how.
what? You just smart as second period. So hopefully a lot of you guys are right.
Wait, just as smart?
Just as smart.
What is your second period?
Equal.
Oh, yeah, we're smart.
Okay? They're smart too. Most of them got this buzzer right. Let's see if anybody got it right here.
There's.
Okay. Let's see. Did anybody get an expression for X that they would like to share with us? All right, Zach, very quick, what do you think it is?
Yeah.
You sure? Do you have something there?
Well, I have an equation, I didn't go all the.
Well, does anybody think they have it then? Well,
I got it.
what do you think it is?
7 cosine of theta.
Thank you. 7 cosine theta.
Thank you.
And what about the y?
Why?
7 sine theta. Anybody get 7 cosine theta, 7 sine theta? Yes. Very good.
Well,
All right, there's a little dimmer in fifth period. Okay, we'll have to do a refresher then. All right, here's what you do. All you have to do is this. The cosine of theta is the adjacent over the hypotenuse.
I got there.
And if you want to solve for x, could you multiply the 7 up? And sine of theta would be the something was it? Opposite over the hypotenuse. And if you multiply the 7 up, there it is. 7. Okay. And there you go. Now, you may recall way back in chapter 1 in vectors. To write a vector, the formula is magnitude cosine theta and magnitude sine theta. This coordinate is right 7 cosine theta and up 7 sine theta, which is where we got all of our vectors from. That's a good reminder. Now, do you get to know vectors on this test? No. But very soon we start to review. One of the first reviews is on this right here.
So the first review is on vectors?
So yeah, I think the first one we do has a few vectors on it, a few other things. So kind of put that in the back of your head there, all right? That magnitude, cosine, magnitude, sine, all right? And that's where it comes from right there. So very important. All right, we'll do a lot of reminders today that you won't need for the test, but are good to be thinking about. Okay, so that's the buzzword. Now, let's go on to the first problem, and we have a triangle. The feature today is all about triangles. You may recognize a lot of this from that old class that everybody refers to as geometry. And you maybe even did some of this in Algebra 2, so this will be a review for you. You'll say, oh yeah, we did that way back there. But we're going to put it back in your heads. Okay? For the final exam, because somebody determined that on the final pre-calculus exam, it is important to do Algebra 2 as well.
Wait, so they wrote the exam for us?
The exam's written for us. That's the one I took the other day. Like I actually went to the place and took the whole exam myself.
Oh, yeah, it took you like...
I got 100.
A few minutes, got 100, yeah. But that's not important, okay? The important part is that I took it and I said, oh, my kids will ace this. You guys will know this, okay? Yeah.
Were you the first to finish?
Okay, now, okay, in this, I'll tell you that Rainbow teacher though, she's quick.
Yeah, she's quicker.
She's right.
What, only a half hour?
Yeah, of course, we put the stats up here, full weight.
I zoomed the camera off.
Oh,
You're good.
we're in business. Okay, all right, anyways, it's true though. Okay, of the whole school, like all the seniors, like even the standard seniors, like everybody? Like every senior in the entire school, that's really good.
That's a multi-day.
No, like all seniors, period. Like your senior class, it's really good, very high.
Yeah.
Okay.
I will Brentwood and Ravenwood.
Hey, we got them. All right, we got next year too, with you guys. Okay, now, here's this. First things first, label your triangle, all right? Let's make this an ABC, just to make it easy. Now, it doesn't really matter where you put the A, but let's go together and let's put the A up here, the B over here, and the C over here. Do you remember from geometry that angles are labeled with capital letters? Remember that? Sides are lowercase letters. Do you know where the lowercase a goes? A goes across from the capital A, so on the bottom. And the lowercase b across from the capital B, and the lowercase c across from the capital C. So that's how you label in geometry, right? We're going to bring that back for pre-calc, right? And try to, since C and lowercase c look the same, try to make your capital C really big. Okay, one more thing. I am perpendicular to the base, therefore my name is what?
90.
Okay, what is my name if I'm this line right here?
So
I must be the what of the triangle?
Height.
I must be the height of the triangle because a height is perpendicular to the base. That's not a height. This is a height, isn't it, right?
Sure.
Okay? I wonder how tall your ceiling is, Mr. Wade. Well, let me put a piece of string under my foot and put it to that corner right there. Yeah. Okay? I made your house with that 20-foot ceilings like you wanted. Mm-hmm. Sure. Okay, no. This is up and down, okay? All right? How tall is the basketball goal? Okay, you get it, right? Okay, so up and down. Okay, it's a 100-foot tall basketball goal.
I don't get it.
All right. So here's this. Now let's do this next. Let's start with the sign of capital B. Write that down. Sign of capital B. The sign isn't sign something over something. Opposite over hypotenuse. But now here's the trick. Don't go to B over, it doesn't work. Sine, cosine, the whole SOHCAHTOA thing. Did you know that SOHCAHTOA only works for right triangles?
Yes.
And that's it? So when you, okay, where's the right triangle? It's not across the B.
It's 8.
Yes, the right triangle is right here. Okay? So from the sign of B, it would not be B over C, it would be H over C. Okay, in the right triangle only. Okay, now, let's also do the sign of capital C. Make that a big C there. The sign of capital C, by definition, what would it be in this triangle? H over B. Opposite over adjacent again, right? Or over hypotenuse again. Okay? So it's H over C, it's H over B. All we're doing is just opposite over hypotenuse. That's pretty easy. Okay? Now wait a minute. I see something in common though between these two here. They both have a what?
C.
They both have
Opposite.
an H, don't they? Yes, they do. Opposite side. Yep. Let's solve for H. Let's see what happens here. Just out of curiosity. How do you get H by itself here? Okay, C sine B. Multiply it up. Lowercase c sine capital B. And if you solve for H in this one, it would be lowercase b sine of capital C. Now wait a minute. There's a property in math that says if A equals B and B equals C, you can cut the middleman out, the A equals C. The transitive property, that's a plus 10. That's okay. Natty Mike, you got it in second period, so it's only fair that you get it as well. I wanted to see who remembers their properties and not to do anything over spring break. Okay, now, by the transitive property, is it not true that C sine of capital B would equal B sine of capital C? Isn't that true? Right? And also, is it not true that you can divide both sides by lowercase b there and lowercase c there?
Not true?
It is true.
Oh, I was like, what you just said. Okay.
I'm using my courtroom manner. And, Your Honor, is it not true that that is a law we've already learned before? The law of sines, and you can throw in one more thing that is also true. The sine of capital A over lowercase a. And that is the law of sines, and we just proved it. And all we did was do opposite over hypotenuse, and set them equal to each other. And there it is, right there. And you saw it in geometry, and you probably saw it in algebra 2 as well. I think. Because as Ms. Foster says. All right, so it's back there somewhere, so you learned it in 2 classes, well, here's class number 3. All right, so that is the law of sines, and in the box, you can actually write law of sines. Or you can put that in the box, doesn't matter. Either. Okay? And all we did was use a little SOHCAHTOA, and we proved the whole thing, right there. Makes sense. So the ratio between the sine of an angle and its opposite side will always be consistent, no matter how big the triangle is, how small the triangle is. And by the way, law of sines does not just work for right triangles, it works for every triangle, no matter what it is. Okay? So that's a good theorem right there, good formula. Okay, now let's do this next one here. And this kind of relates to the buzzword as a matter. All right, we have a vector. You just think of it as a hypotenuse, basically. The word vector scares you. Okay. All right. Now, didn't we just do this in the buzzword? If you have theta and a is the hypotenuse, or a vector, what about the x component, y component? What is this component right here? That would be magnitude, cosine, something theta, theta. And the height would be magnitude sine theta. And that is always true. How do you know that, Mr. Wade? We just use SOHCAHTOA, right? Actually, we just use SOHCAH. We didn't get the TOA part, okay? I just use SOHCAH, and I made this happen right here, okay? Therefore, that coordinate up there, wouldn't that coordinate be a cosine theta, a sine theta? Again, remember this for the review, not on this test, you won't need this on this test, but it's helpful today to prove this, okay? But you will need it on the reviews. Okay, so that is the coordinate. Now let's drop down to the next level here. And we're going to use the exact same vector A, but instead of going straight down, I'm going to go diagonally down and back this way. So this triangle is like right here. Okay? So we're not going to go the full distance to the corner, just this. I just made some random triangle. Okay? And I'm going to make ABC. So this is just some random triangle, okay? Now let's see what happens. Isn't this top coordinate still the same exact thing?
Yes.
It's the same picture, I just modified it. So that's still the same point by SOHCAHTOA over there, or SOHCAH. Okay, my SOHCAH. All right? Now, down here. Do you know what coordinate this is right here? I bet you know this one. 0, 0. I'm going to go to the right B.
0, a cosine.
No, I'm not going to go all the way a cosine theta, I'm just going to here. Wouldn't it just be right B up or down 0? B 0? Yep. That's it, just B 0, just keep it simple. Okay? So that point is B 0. That point is a cosine theta, a sine theta, from what we talked about earlier. Now let's see if you recognize the proof. I wrote the proof out for you. There are like 5 or 6 proofs of the law of, this is a certain law, okay? There are 5 or 6 proofs of this, but I picked my favorite proof of all of them. I like this one the best. Okay?
Wow.
Does anybody know where I got C equals long square root of all that business? What's that?
Pythagorean theorem.
Pythagorean theorem, otherwise known as
Distance.
distance formula. That's exactly what it is. Isn't it the distance between these 2 points right here?
Yes.
Can you, now look in the formula. Can you see x2 minus x1 and y2 minus y1? Okay? Matter of fact, label them right now. x2 minus x1, y2 minus y. Okay? Label that up top. Okay? So basically, we're just doing the distance C is all we're doing, right? That's it. Okay? So in the blank, to identify this, let's call this the distance formula. All right, now, how do I get to the next step? Let's see what happened here.